Okay, let's do the addition rule day 2. We're still working with mutually exclusive events. And we got 3 more examples we're going to look at, or 3 more types of examples, I should say. All right, so the frequency distribution shows volumes of sales and the number of months in which a sales representative reached each sales level during the past 3 years. So we've got 3 years going for this table. Using this sales pattern, find the probability that the sales representative will sell between 75,000 and 124,999. There we go. I was saying that wrong. Sorry. So here's the deal. This particular example is not actually to do with anything mutually exclusive or anything like that. What you have to watch here is 3 years. So 3 years times 12 months a year is 36 months, because these numbers right here in this column are all months. And we want to know the probability that they sold between 75K and 124,999. Well, 75K to 100. Okay, so it's these two numbers right here. So you add 7 plus 9, so it's really 7 plus 9 over the 36 years that we have, and that is 16 over 36, which is 4 over 9, which as a decimal would be 0.444. All right, find the probability that the sales representative will sell between 0 and 49,999. Okay, again, not really mutually exclusive. You're just finding these two numbers right here. 3 plus 5 is 8, divided by the 36 months that this covers. And 8 over 36 reduces down to 2 over 9, which is 0.222. Okay, so a simple one to start, really just getting us into working with a table. All right, this one's a little bit more complex. So the blood bank catalogs the types of blood, including RH status, given by the donors during the last 5 days. The number of donors who gave each blood type is shown in the table. So your columns represent your blood type. You've got type O, A, B, and AB. Your RH factor, you can either be positive or negative. Okay? So find the probability that a donor selected at random has type O or type A blood. Here's the deal. You can't have 2 types of blood. So this is actually mutually exclusive. So it's a very straight up, very simple, we're just going to do probability of O or A is just going to be the probability of O plus the probability of A. That's all you have to do for that. So your probability of O, there are 184 people that are O type. There are 164 people that are A type. Okay, so we are just going to add those two together. They will be over 409. There are 409 total people that did that donated. I apologize. So when you add those two numbers together, add those two fractions together, the probability that they are O or A will be 348 over 409, which is 0.851. Okay? All right, the next one, probability that a donor selected at random has type B blood or is Rh negative. Here's the deal. You can be, you've got a blood type and you've got an Rh factor, so those are not mutually exclusive. You have overlap on there. So when we do this, the probability of B or Rh negative is going to be the probability of B plus the probability of Rh negative minus the people who are both B and Rh negative. Okay? So our probability of B, we have 45 people, right, that are B. So there's my 45. Oh, I'm sorry. I should probably do like different colors for that. Let me see what I got. I don't have a lot of colors on here. We're gonna have to stick with what we had. Sorry. All right. So there are 45 people out of the 409 total that are B, plus probability RH negative. I'll go to green. That's not going to show up very well. I can't even pick a nicer, like, darker green or anything. Let's go with a well, let's go with an aqua, see what that does. All right. RH negative, there are 65 total people that are RH negative, right? So 65, that doesn't really show up very well. I'm sorry, guys. Well, it doesn't for me. Hopefully it does for you guys. Over 49 minus 409, sorry, not 49, minus the probability of people that are both B and RH negative. So both B and RH negative, that is 8 people, right? There's 8 people, because what you do is you find the intersection of the B column and the RH negative column, and they intersect right there, so that's 8. So you subtract 8 out of 409 from that. Okay? And then when you simplify, or when you get that fraction, it's 102 over 409, which is 0.249. Okay? All right. Find the sorry, I didn't realize I had one more down there. Gotta shrink it no, I don't have to shrink it. I don't know why it's not there. Should be there. I have another one on your notes, on your on the PDF of your notes that I should be doing, but I'm not sure. So it's example C for that. Okay, so it says find the probability that a donor selected at random does not have type O or type A blood. So probability of not O or not A. I don't know why I don't have that. Really, guys, it's easier to do nots when you do 1, meaning 100%, minus the probability that they are O or A. So you oopsies, I can't really write that over there, huh? That doesn't really show up, okay? So probably not O or not A is the same as doing 1, and you use 1 because you've got 100%, that represents our 100%, okay? So probability O or A, oh, there it is, okay? We already found it. So what you do, okay, you are going to take, give me 1 second. Sorry, guys, I didn't realize it wasn't there. 1 minus that 850 or 0.851 that you found. So 1 minus 0.851. Sorry. And so it is 0.149. I apologize. I did not realize it was not on there. I wonder what happened. Must have, I don't know, just disappeared when I created the file. Oops. Sorry. We don't want to be on the screen. I didn't want to add a new screen. I just wanted to go to the next screen. Sorry about that. This next screen, I'm not really going to spend too much time on it because it's in your notes. It's a nice PDF. It's just a nice little chart that summarizes, what the types of probability are and the rules, and gives you a nice little example of them in words, and then kind of gives you something, like this is what we've been working on in this section right here, right? But we've also done, dependent versus independent events. So it just kind of helps you out. It's just a nice thing to have up as you're working on the MyMathLab, just to have it for reference. All right, last example. So when you're looking at this, use a figure to find the probability that a randomly selected draft pick is not a running back or a wide receiver. Remember, doing not a running back or a wide receiver is the easiest way to do it is 1 minus the probability that they are a running back or wide receiver. Okay? So you can't be, well, for the sake of this, we're going to just assume that you can't be a running back and a wide receiver. So we're going to be mutually exclusive events. So we're going to do 1 minus, okay, the probability that you are a running back, good grief, running back, 23 out of 253 players. So 23 out of 253 players plus 31, right? 31 wide receivers. 31 out of the 253. So 31 out of 253. Guys, really, honestly, just write it down so you have it, and then just plug everything into your calculator. But really, it's going to be 1 minus 54 over 253, which is 1 minus 0.213, which is 0.787. So that's your probability that you are not a running back or a wide receiver. So find the probability that a randomly selected draft pick is not a linebacker or quarterback. And again, easiest way to do that is 1 minus the probability that they are a linebacker or quarterback. Okay? So when you look at this, I'm going to slide this up just a little bit. Okay? When you look at this, you're going to do 1 minus probability of linebacker. Linebacker is 30. We got 34, right? Right? Yeah, 34. There's my 34. 34 out of 253 plus probability that we're a quarterback. Oops, sorry. Quarterback, we got 15 out of our 253. Oopsies, 253. I don't know what I'm writing there. Sorry about that. So this is 1 minus 49 over 253, which is 1 minus 0.194, which is 0.806. Okay, sorry about stumbling through the last half of that. I don't know, not having that part C of that other example kind of threw me off for the rest of the video. Sorry about that, guys.